Integrated circuit 13, digital circuit memory. There are many different type of memories. Static memory, which is a very high speed memory, still used in some communication areas, but used to be used in mainframe computers. Nowadays, the supercomputers are all LSI chip, the parallel architecture, so they don't need this type of memory anymore. But it's good to understand how it works. Basically, it's a latch. So each bit is a latch, so it costs a lot of silicon chip area. So you cannot have very high density. For example, say you have a 4-bit address here and a 4-bit address here. The address decoded into 16 lines, and this is 16 lines, and you select one of latch, and the latch has a enable gate. This enable gate is selected, then the data is going to be enable gate. This enable, the data is going to be written. Okay, so suppose this is one page and you have many pages, depend on how much you can cram into the silicon chip. Okay, the read operation is very straightforward. It's just address decoder. After you decode address, data come out. So this is access time. Okay, the write operation is, since it's latch, you have to give a pulse. So after address decoded, you need to provide a pulse, and there should be some time before pulse start, and the pulse should end before address change again, and there should be a duration of pulse specified in order to make this latch data transfer works. Okay, so these are the static memory, and usually it's very high speed, like ECL circuit. Emitter coupled. And this goes to this, or this goes to this, this goes to this. It's a feedback loop. This will make a latch. Okay, so static memory. Most of CMOS, most device use the dynamic memory, and dynamic memory is same latch, but each one you charge up the capacitor. If capacitor has charge, then it's act as 1 or 0. If charge discharged, the 0 or 1. Okay, so there is an enable gate, and the same story, address is decoded, and select the 1 bit. This bit is basically capacitor. Why you do that? Well, you don't need latch. Latch needs many transistors, and single capacitor is so small you can have a higher density memory. But this capacitor cannot hold the charge too long, only a certain specified time. So what's happened is you have to refresh the charge. If there is a charge, the charge is discharging slowly, and if about certain threshold, if you detect, then you have to charge up again, and you have to repeat this operation for every cell. So there is the refresh counter, which act as the address. Refresh counter act as an address. It's decoded and go one by one and refreshing. If there's no charge, then it doesn't charge up. Okay, so it's just access only. You don't have to. It's a self-writing access. So if there is a charge, it's charge up. If not, it doesn't charge up. So that's why dynamic memory need refresh operation. And the refresh operation together with memory read and the write operation, three operation is mixing up. Okay, so address generation counter for a refresh operation is sharing memory access. Okay, who share the memory access? Refresh. And the memory operation. Memory operation is read and write. Okay, so the write operation is regardless the capacitor. If you need to charge up and it wasn't charged, then you charge up. If charged up and you have to discharge, then you discharge it. Okay, so generally speaking, dynamic memory is slower, but it's such a small bit, you can cram in so many on a single memory chip. So high capacitor memory chip is all dynamic memory. Now programmable memory. Okay, the field programmable read-only memory. This one has a fuse, tiny fuse on a silicon chip. The array of this configuration, and the fuse has a pull-up register here. And what's happened is, if fuse is on, live, then this goes high. If you wait a minute. So if fuse is blown, this goes high. If fuse is intact, then this goes low, because fuse electricity is much lower than this register R. Okay, and what's happened is there is the gate transistor here, and when you select this and increase the voltage like this, then suddenly this large current flow and the fuse is blown. Okay, so if fuse blown or not makes high or low. So you have an array of memory, the fuse, some of them blown, some of them intact. So you get the table of 0 and 1. And this is called ROM. Is you do this fuse by IC process mask. You make a mask, and mask determine it's connect or not. That's the ROM. If you put F, programmable P, and F, field programmable ROM. So field programmable read-only. This is a read-only ROM, and the field programmable means after chip is made, using a software, you can determine which bit to blow, then create a table, memory table. This is field programmable ROM. Okay, and it's there is ROM called EEPROM. EEPROM is not a fuse, but what it is you apply voltage, then you charge up in the channel and short circuit the transistor, and that stay for 10 years, so it's reliably used. But when the light is exposed, then this charge is discharged on the silicon, then you can erase all the memory. So EEPROM typically has a little window in the middle of chip. And after you program EEPROM, just like field programmable ROM, you put the stick on it and shut off the lights. But if you want to change the contents, you remove the sticker and expose the high intensity lights, then entire chip, this programming is erased and you can reuse it. Okay, and this kind of device is often used. So the beside that, there's a recently you cannot erase it, but you can program it slowly. You can change it by changing power voltage and stuff. So the slow write and fast read type of field programmable ROM. Okay, this is so-called non-volatile memory. Non-volatile means there's no window, so once you write it, it's there, but you can rewrite it, and the writing operation became very simple, just like a regular memory write operation. So you can change the content. So non-volatile memory is a USB memory. Those memories are non-volatile memory. It's basically same as those EEPROM. It's a charge up certain area of transistor and short circuit, and this charge stays there for a long time, or over 10 years. So it's reliable. Okay, so non-volatile memory is kind of EEPROM without window, and write operation is very simple without changing the power voltage. So it can be done just like you can use it just like a regular memory chip. Okay, but usually writing operation is slow because you have to charge each bit, but the reading is pretty fast because it's just address recording and get the data out. Okay, that's the characteristic of non-volatile memory. Okay, I hope you enjoyed this video, and if you like, subscribe.